Okay, lesson 5.7, completing the square. So this is a process, a strategy used to solve quadratics. But before we begin, we need to review a skill, which is that of being able to break down a perfect square trinomial. So as you can see, we have at the top of the page perfect square trinomials. So on this page, I have just for you the positives. Let's add the negative to that, which should have been on here. I just forgot to put it. And the negative 1, of course, breaks down to x minus k times x minus k, or properly written, x minus k squared. Okay, so rewrite into perfect square form, and then we're going to factor. So perfect square form means you're going to be able to look at those trinomials, and you're going to be able to recognize that they are perfect square trinomials, and therefore you're going to break them down very easily. So you ask yourself, looking at the first term, is that a perfect square? Yes, it is. What times itself gives you x squared? The answer is x. Then you look at the third term. What times itself gives you 4? And the answer is 2. And if this is addition here, then you're going to put addition here. And it's always important that you take the time to verify that it is in fact a perfect square, which means you would say 2 times x is 2x and doubled is 4x. Remember, the middle term always has to be double the first and last terms multiplied together. So we always have to double check that. And so our answer here is x plus 2 squared. We have taken the trinomial given to us and we have factored it down into its 2 factors. So we just write the squared on the outside because it's the simplest way of writing x plus 2 times x plus 2. Now I do have students that will do it that way first and then write it as squared second, and so I'm going to do the second example that way. What times itself gives me x squared? The answer is x and x. And then factors of 25. What times itself gives you 25? The answer is 5 times 5. They have to be perfect squares. And since it's a positive in front of the 10x, I'm going to put a positive in both parentheses. So my answer, more formally written, is x plus 5 squared. And when you multiply 5 and x together, you get 5x. When you double it, it does in fact equal the middle term, 10x. So that is a perfect square trinomial. Let's break down number 3. What times itself gives you x squared? X times x. And then the last term, what times itself gives you 9? 3 times 3. They're both positive since this is a positive. And more properly written, x plus 3 squared. Okay, so now what we need to do is we need to think about the pattern that is formed here. So describe the pattern you see between the middle and the last terms of these perfect square trinomials in standard form. So I want to know the middle term 4 and the last term 4. So this is the middle and this is the last in that first trinomial. Middle term in number 2 is 10. Last term is 5. Middle term in the last one is 6. And the last term is 9. I want you to take a minute. If you have to pause the video, that's fine. And see if you can figure out, is there some sort of pattern here? What is happening with my numbers? This should be a 25. Let's fix that, sorry. So what are the patterns? 10 and 25, 6 and 9. I'm hoping that you're recognizing that this is 2 plus 2, and that this is 2 times 2, and that this is 5 plus 5, and that this is 5 times 5, and that this is 3 plus 3, and that this is 3 times 3. So there's a relationship happening here. So what's happening in this second part is that we're squaring the term, okay? And then this one is we're adding the 2 terms together. And so the relationship we're hoping that you're seeing is that the last term is 5 squared, and 5 is half of 10. Let's see if this one works. So this is 2 squared, and this is 2 plus 2. So I need this 2 to be half of the 4, and that's correct. 5 is half the 10. And then this is a 3 squared, and 3 is half the 6. So the last term is half the middle term squared. So the last term, the 4, the 25, the 9, is half the middle term squared. So 4 is half of the middle term 4, which is 2 squared. 25 is half the middle term. Half of 10 is 5, squared is 25. Half of 6 is 3, squared is 9. Okay? This is something that's going to be really helpful, knowing that that pattern happens in every perfect square trinomial. The last term is always half the middle term squared. We're going to use that to help us. So underneath the box it says the process of finding the last term of a perfect square trinomial is called completing the square, making the trinomial into a perfect square trinomial. That is when it's not already a perfect square trinomial. Not already a perfect square trinomial. And since it's not, we're going to make it into a perfect square trinomial, so then we can factor it easily. So we're going to use this following relationship that we just discovered to write this equation, which says x squared plus bx plus half of b squared. The last term is half the middle term squared. And then what happens is when you break it up and you get it into its form, this is half of b, that last term. So look up at our examples. 2 is half of 4, 5 is half of 10, 3 is half of 6, so half the middle term. All right, so I'm going to scroll the screen up here, and we're going to take a few minutes and practice seeing if we can at least just find what that term is, how you get that last term. Okay, so clear the screen, scroll the page up, and let's find some missing pieces. So in this first example, what we're asking you to do is just find the missing value that we would use to complete the square. So the last term is going to be half of the middle term squared. And so we don't worry about the sign here. We just take whatever that value is for the middle term, 8. We divide it by 2, and we square it. 8 divided by 2 is 4, and 4 squared is 16. So 16 would make this a perfect square trinomial. Half of 8 is 4, 4 squared is 16, so that actually works perfectly. Second example, sometimes that middle term is odd, and what do you do when it doesn't divide evenly and become a whole number like the first example did? Put b in the equation, 7 over 2 squared. When you square a fraction, you square the numerator, so 7 squared, and you square the denominator, 2 squared. 7 times 7 is 49. 2 times 2 is 4. So the fraction 49 over 4 is what makes that a perfect square trinomial. They get a little messy when there are fractions, just like all the things we deal with when we're dealing with fractions. All right, last example, b over 2 squared, half of b squared. 20 divided by 2 is 10, and 10 squared is 100. So 100 is the number that makes that a perfect square trinomial. So we've done all of the pre-work that we need to do in order to learn the strategy of completing the square. We know how to break down a perfect square trinomial. We know the relationship is that half the middle term squared gives us the last term. Now we're going to use all of that to actually complete the square. And so we're using the example x squared minus 12x plus 5. You're going to rewrite so that all the terms with the x's are on the left and all the constants are by themselves on the right. And you need to leave a space because we're going to create a perfect square trinomial. This trinomial given to you is not a perfect square, so it will be very difficult to factor it. So let's go ahead and set it up. So it's going to say x squared minus 12x, and we're going to leave the box so that I can figure out what number I'm going to put in there to make it a perfect square trinomial. And we've moved the 5 to the other side of the equation, so now it's negative 5. And then I'm also going to put a box over here. And the reason why I put a box on that side too is that if I'm going to add some value to the left side of the equation in that box, then I have to add the same value to the other side of the equation, or my equation is no longer balanced. So whatever I do to one side, I have to do to the other. Okay, so now I'm going to do half of b squared to find out what I would put in my equation. So half of b squared. b is 12 divided by 2 squared. So 12 divided by 2 is 6, and 6 squared, 6 times 6 is 36. So now I have x squared minus 12x plus 36. Now I have that's a perfect square trinomial, equals negative 5 plus 36. And the question now is, let's factor the trinomial. So we need to figure out what we're going to get here when we factor it down. So I know that this is a perfect square trinomial. And if it is, then I know that I can break it down really easily into its two parentheses. X times x gives me the x squared. And 36 is 6 times 6. And it's a negative symbol in here, so I'm going to put negative symbols in here. Equals 36 minus 5 is 31. And then I'm going to move this down. We're going to factor this. So it's going to say x minus 6 squared equals 31. How do you solve this? We solve by finding the square roots. So in other words, the left side of the equation is being squared. And the only way to undo a square is to take the square root. Squaring something and taking the square root of it are inverses of each other and cancel each other out, leaving us with just our variable. That's very important. That's what we're trying to get, x by itself. So I'm going to square root both sides, and I'm going to run out of space here, but you can just keep right on trucking. Right? So we're going to square root both sides of the equation, and in doing so, the square root and the square cancel, leaving me with x minus 6. I don't know what the square root of 31 is because it's not a number that is easily broken down into square roots, into perfect squares. And rather than giving a long, nasty decimal answer, it's way more accurate to say the square root of 31 than it is to give some decimal that you've plugged into your calculator for the square root of 31 and then rounded. You don't want to use rounded answers if you don't have to. So we're just going to use plus or minus square root of 31. It's way more accurate than giving a rounded decimal. If you plug square root of 31 into your calculator, you will inevitably get a decent decimal that you will have to end up rounding, and then you've changed it in some way. You've made it a little less accurate by rounding it. And then the only thing we have left to do now is to get x by itself. So I'm going to add a 6 to both sides. And so what we're going to ask you to do in writing your answer is to make sure that you put that whole number first. So don't tell us plus or minus square root of 31 plus 6. Sometimes that looks like this, for those of us who are sometimes in a hurry and sloppy, and the question is going to be what's under the radical and what's not. And so you don't want to be really kind of skeptical about what's under there or what's not, so we put the whole number first, 6 plus or minus the square root of 31. And this is actually your answer. And remember, in solving a radical or solving a quadratic, what we're looking for are the roots. Right? The roots, the solutions, the zeros. I'm looking for where does this particular parabola cross my x and y intercepts. I'm wanting to know where it crosses the x. I want to know where this parabola crosses the x-axis. So if you take this and you try to figure out what does that mean, this answer actually means actually means 6 plus the square root of 31 and 6 minus the square root of 31. There are your two roots. But how do you graph that? So you plug in square root of 31 on your calculator and add 6, and you get 11.56. We're going to call that 11.6. We're rounding it. This is not a very accurate method. And then we're going to say 6 minus the square root of 31. I don't know what's happening with my marker right now. Hang on. So let me see if I can get my eraser to work. My marker's going crazy. Okay, sorry. So we have 6 minus the square root of 31. So you're going to plug that into your calculator and you're going to get negative 0.43. These are the two places where your parabola crosses the x. So negative 0.43 we'll put here, and maybe 11.6 we'll put here. And so your parabola would cross in those two places. So those are your solutions. This is the process of completing the square.